a break.
Yeah. After Monday, we're off. Thanksgiving break. Well, actually, we have to do school that week, but
Well,
we got 2 weeks to do 1 week of assignments.
so I'm gonna do 1 week of assignments, and then I'll still have these, but do I have these? I'll probably have to finish them.
Wednesday. Okay. Next week, no, yeah, I'll do it right.
No, I'm not gonna see.
Is it here on time?
I can't, I gotta see. No, it's
Number
like
2.
3 minutes.
You're 3 minutes
The
late.
sine of theta is the square root 2 over 2. Cosine of theta is negative square root 2 over 2. Tangent of theta is negative 1. The cosecant of theta is the square root of 2. The secant of theta is negative square root of 2. The cotangent of theta is negative 1. Number 4. The sine of theta is 0. The cosine of theta is 1. Tangent of theta is 0. Cosecant is undefined. Secant is 1. Cotangent is undefined. Number 6. Sine is negative 3 times the square root of 34 over 34. Cosine is 5 times the square root of 34 over 34. To be clear, if you wrote cosine is 5 over the square root of 34, that's wrong. At least partially. You must rationalize it. Continuing on. Tangent is negative 3/5. Cosecant is negative square root of 34 over 3. Secant is square root of 34 over 5. Cotangent is negative 5 over 3. 8. The sine is negative 2 times square root of 5 over 5. The cosine is negative square root of 5 over 5. Tangent is 2. The cosecant is negative square root of 5 over 2. Secant is negative square root of 5. The cotangent is 1/2. Number 10 is 0. Number 12 is negative 1. Number 14 is negative 1. 16 is undefined. 18 is in quadrant 3 and 30 degrees. Number 20 is in quadrant 4 when you draw it, and it's pi over 3. 22 is in quadrant 4 when you draw it, and 75 degrees. 24 is in quadrant 1 when you draw it, and it's pi over 6. 26 is square root of 3 over 3. 28 is negative 1. 30 is negative 2 times the square root of 3 over 3. 32 is negative square root of 3 over 2. 34 is on a different page. Let me go on a side quest. Sine is 1/2. Cosine is negative square root of 3 over 2. Tangent is negative square root of 3 over 3. Secant is negative 2 times square root of 3 over 3. Cotangent is negative square root of 3. 36. The sine is negative 5/13. The cosine is square root of 3 over 3. Tangent is negative square root of 2. Cosecant is negative square root of 6 over 2. Cotangent is negative square root of 2 over 2. Oh wait, I just read
What?
37.
Yeah, okay. I was confused for a second.
38 is sine is negative square root of 2 over 2. Cosine is negative square root of 2 over 2. Tangent is 1. Cosecant is negative square root of 2. Secant is negative square root of 2. 40. Sine is square root of 3 over 2. Tangent is negative square root of 3. Cosecant is 2 times square root of 3 over 3. Secant is negative 2. Cotangent is negative square root of 3 over 3. 42 is negative 6 square root of 3, 6, or negative 10.46. 44 is the sine of 315 degrees. Yeah, it's also negative square root of 2 over 2. 46 is negative 1. 48 is negative square root of 3. 50 is undefined. 52 is 2. 54 is negative 2 times the square root of 3 over 3. 56 is square root of 2 over 2. And 58 is negative square root of 3 over 2. What questions you have?
32.
Either 2 or 6.
We do 4 instead of 2 or 6.
I got 4 completely right. I got the other 2 wrong.
Well, I just need to know how to find the hypotenuse of 4. Is it just two?
I need to know how to find the R.
Pythagorean theorem.
Well, but
Forgot
it's a
how to
line,
find
it's not a triangle.
There's- You're thinking about it wrong. You're thinking about it wrong.
So is the hypotenuse two?
There isn't a hypotenuse.
X is 2, y equals 0, and R is 2.
So it is two. Okay, that's what had me wrong.
Okay, I have a
32.
question about 2 or 6.
Okay, 32.
We can do 34.
32, the sine of 300 degrees. We are asked to find the exact value. So it's over here.
Yep.
What's the reference angle?
30 degrees.
30
Yeah.
degrees.
No, 60.
60 degrees.
Oh, I forgot the other direction.
It's
Always
the-
going to the x-axis.
Oh, that's, I got all
Found
of those.
the problem. What other questions do we have?
Can we do 36?
Okay.
36.
And then 48.
And then 6. And smack you if we don't do 6.
Well,
And then, like I'm saying, and then 40.
And then 6.
No, 6 and then 48.
That's fine.
And
Whatever, it doesn't
then-
matter.
Where's that from? That movie with
Whichever
the car?
one.
I think it is.
What?
That's a stupid movie.
What?
Which one?
I like stupid.
Dude, where's your car? Or my car? Dude, where's my car? I think so. Ashton Kutcher and what's his face? And he doesn't have some stupid romantic partner.
Yeah.
So that's a win.
It is a word.
Why can't we have a comedy movie without a romantic? No, there's only 0.
Well, I'm talking about specifically an Ashton Kutcher movie. Like, always doing stupid stuff.
That's why I thought no. Because there's singles.
There is a
Comment number 2 is we got.
I would say Jim Carrey is one of the most overrated actors ever, but Eternal Sunshine of the Spotless Mind exists.
I don't know about it.
So, you know. Although it is overrated, I think any comedian playing a straight role in a film that the rating of the film gets overinflated.
Yeah.
That is definitely a thing that happens.
What do you do?
Okay, what should we do? First of all, figure out where it could be, right?
Yeah. Yeah.
Wait,
Where is cosine negative?
anywhere but
Anywhere
right
with
side.
the top left. Oh,
Left or
top,
bottom?
bottom right. Sorry.
Top left.
Yeah, that was a weird way
Swap
of saying it.
corners. And
Anywhere
it's
but
in
right.
the
Zero or
bottom left because the sign is negative and so is the
Wait,
cosine.
no.
It's
This
bottom
cosine is
left.
positive in the bottom right.
Yeah.
So it has to be bottom left and top right. Because all students
It's
take
bottom left.
calculus.
Yeah.
That's what I'm
The
saying.
top
It's bottom
right
left.
is positive.
Yes.
Everything's
The
positive.
bottom
Can't
right.
be that.
The bottom
So, no,
right.
it's the
It's
left
bottom
side
left.
where it can be. It
Bottom
can't be bottom
left.
You
right.
mean negative and bottom left?
It's the
Top left.
It has to
bottom.
be the left side.
The left
Left
bottom
corner.
That's true.
That was the most screaming. You done with it so far.
Negative, negative, positive. Isn't the tangent being positive in the bottom left?
Bottom right tangent's positive. Wait.
Tangent is
Left,
positive.
Yeah,
I'm-
all student.
left. That's the left.
So all in calculus.
Cosine is negative and the sine is negative. Why is that a question mark?
Because it
It's
has
where it can be negative.
Where
has to be in those two
cosine can be
Okay,
negative.
I'm just getting confused by the question marks.
We're narrowing things down. It's one of these two. Sine is negative, so it's this one, right?
Yes.
Great. So it's over here somewhere.
Yes.
Great. We did it. Look, Mom.
Like the
What is cosine?
Cosine.
Oh wait, never mind. I
Cosine
figured it out.
is
I
opposite
figured out what
over.
the problem was.
No, wait. Opposite over. Wait. Hypotenuse.
It's x over r.
X over R.
So we
Yes.
have to find R. But we have R.
gotta find y.
Wait a
Yeah.
minute.
So
Use the
staggering
hypo-
theory. Did you figure out what you did wrong yet? Who
Yes,
asked for this
yes,
one?
I figured it out.
Oh,
I had it in the wrong area.
Wrong quadrant.
I put it in the right one.
That's what I did.
I didn't do that.
Number
Making
6.
sign has to be.
Number
right.
6.
I forgot how to get to R.
And then
I did
48.
the way the book told me to, and then it like,
You squared,
Didn't
it's
work.
Pythagorean theorem. It's squared
Yeah.
plus squared,
but
square root.
I don't know what happened. It like all died.
25 plus 9.
It is R equals square root of x plus
Alright, that's what it is, yes.
y.
Yes.
You said number
That's
6?
correct.
Yes.
Okay. Uh-huh.
It's in the bottom right corner.
What? X, Y. Oh, okay. Yeah.
Yeah,
I don't know why.
That's how plotting points works, Malcolm.
I don't know why, but for a split second,
Don't know why I
I was like, I was swapping the X and the Y for a split second for some reason.
Don't you know how coordinate
Shut it. Shut it.
Okay, so now what?
Find the hypotenuse.
Do the Pythagorean theorem.
So you get the square root
You
of
get-
34.
The square root of 34. What?
Yes.
Oh,
Let's do the positive square
yes,
root.
yes. 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 That's right.
So what do you do?
And then what would we do now?
I can't.
We would find
No, no,
all the
it has to
points
be the
by
positive square
using
root of
the.
34, so then we can start doing all the
Yeah.
5 over.
So the sine of theta equals.
Oh, I know what I did
-3
wrong.
over the
5
square root
and
of
3
I figured it out. I squared the -3 and then like kept it as negative. It was -9. I forgot. So I got 4 instead of square root of 34.
So he got
Yeah.
2 instead. That's
Yeah,
Did I do
Is
the
that
same thing on the other one?
Okay.
probably.
Yep, I did do the
48.
same thing on the other one.
Good job.
48.
Stupid.
48.
How wooed. 48. Cotangent of 510 degrees.
It might just be the same issue as I had on 32.
what was your issue?
510, that's.
I wasn't basing. I might not have been basing it off the x-axis.
What's 510 minus
150.
360?
150.
And then that was the-
So when it asks you to like graph it or something,
30
right?
degrees
It
is
gives
the
us
reference
a
angle
30
to the
degree
top left.
reference angle.
Oh no, it just says find the exact. This one doesn't actually graph it, but it is up over here, right?
Or the
Yep.
30 degree reference.
150.
That's what you do, referencing.
30-degree reference angle.
Yep.
Figured it out. Great.
1, 2.
Any other questions?
As long as I remember how to do negatives, that should be fine.
That would be good.
That's so stupid.
Because.
When you're doing those, just don't even put the negatives in.
Yeah.
Like, cause as you can figure out what the sign needs to be, like, from the little sketch.
Yeah, I mean, they're squared, so it's always.
I have given this piece of advice before, this practice. Most of the time, I never put negatives in the calculator. Most of the time. I just do the rules in my head. And that causes me to make less negative mistakes that way. Because when you punch the negatives, if you do something a little bit wrong, the calculator spits it out, you just, right, you're not even engaging any part of your brain to think, does that even make any sense? So that is definitely the way I do it and the way I recommend to do it. There are a few exceptions where I will put a negative in the calculator, but I very rarely do. Very, very rarely. Any other questions for this lesson?
4.4 notes.
That is what we're about to do. All right. 4-4. Graphing sine and cosine functions.
Ooh, it's purple instead of blue.
Oh no.
Well, you didn't quite get there yet. Keep turning.
Oh, it says it's 4 instead.
You
There we go.
idiot. No, wait.
There we go. Why are you shaking? You have not had that much time.
I was gonna say if I'm looking for
What did you have?
I had 2 active, not 3 active. negatives.
What are those?
I don't know, my mom told me to take better.
But they're
gonna do some graphs. These are likely the first cyclical functions you've graphed. Yes. Most of the functions we've seen have kind of got a static shape. They're also probably the first periodic functions that you've graphed. Periodic means that they repeat.
It's a table.
And a period.
Periodic table.
Yeah, and actually the same idea. So, the reason the periodic table is called periodic table is because the pattern repeats. Right?
The day we use periodic table in math, I'll be very sad.
Why? Periodic table is easy.
Periodic table is easy. It's amazing.
It's quite easy.
It literally counts 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on.
It does. It's counting.
I already used math in my chemistry. I don't need to use chemistry in my math.
Well, that's a silly statement.
It is a silly statement, I agree. But it's still the same.
I'm sure you've used chemistry in a math before. That shows up on word problems all the time.
I haven't paid attention to it.
But does math show up in chemistry? That's the real question.
Yes.
Yes, definitely.
Very much so.
Sort of chemistry are you in?
I'm not in chemistry right now.
That's
Did you
next
already
year?
take it?
I did that last year.
So what do you mean now? Physics?
No, sorry, the year before. I did
Just
physics.
like when we learned
Physics.
other
Physics.
functions,
Physics.
we're gonna start by learning the parent.
Oh, no.
This is the parent function
Hi, Mom.
for a sine function, and this is the parent for a cosine function.
Meet the Parents. That movie? It's
Um,
actually a pretty good movie.
Is it?
I've
You haven't
never
seen
heard
it?
of it.
I haven't seen it and don't want to. I don't like stupid comedies. Bore me.
It's not that stupid.
I'll guarantee you it is.
It really isn't that stupid.
Okay.
It's not stupid. It's not that stupid.
Child, you went into middle school mode for a second. Get out of it.
Calm down, man.
Calm down.
When does the trig function repeat?
No.
In
Wait.
degrees.
In degrees.
When does it repeat?
At 360 degrees.
At 360. In radians, when does it repeat?
2 pi.
Oh,
So-
so you graphing stuff in radians now?
Period
Oh, no.
is 2 pi.
Wait, what's
Or 300. I will explain, child.
period? You're just throwing words out there.
Yeah, I just am saying random words. I feel like you've been in my class long enough to know that I'm not an awful teacher. I might not be the best, but I'm not awful. I don't just start using random vocabulary that's relevant.
The only thing you use random vocabulary with is like random movie references.
Yeah,
We've never seen.
I say random stuff, but not about the math.
You're still teaching a math class after all.
Right? We're gonna split this
Nuh-uh.
period into a few key points.
Ah.
What are some key points between 0 and 2 pi?
Pi.
Half pi.
Half pi. 3 halves pi. 1/6 pi. 1/3
We're
pi.
not gonna do those.
No?
No, we don't need those.
Well, that's stupid.
Oh, shit.
Sometimes we will do those, but
No, that's not a text. That's my Life 360 app.
Who's moving?
My mom.
Oh,
She
shoot.
got at work.
She got to work.
She got at work. She's at work.
She got
what is the biggest number that sine can be?
359
1.
or degrees.
Start punching in your calculator. Sine of a bunch of random degrees.
Sine of 12.
So I guess we don't want radian for this.
Oh yeah, I should probably get out of here.
my
You're welcome.
calculator's frozen.
Oh, okay. Turn it off and on.
That's not good.
1. No, that didn't
It's still from.
Zero, no, wait, I take that back.
The biggest number.
That's the one.
Sine of 360 is 0. Sine of 180 is 0.
Sine of 359.
What?
What the frick? My calculator.
Sine of 1000 is negative 0.9.
Negative almost 1.
Yeah.
So is the biggest number can be not quite 1?
The biggest number it can be is 1.
Oh, it can be 1?
Yeah, what the sign of what is 1? That's on the chart. That would be one of the ones you need to memorize. Just think about it on your unit circle graph. Quit punching buttons and use your brain first.
I thought it would be 36, and I typed that in. Or 360.
What is sine on the unit circle? X, Y, or R?
Say that one more time.
Sine, what is it?
Oh, it's
X or Y?
X. Well, no, it's Y.
Y.
I keep thinking of X and Y flip.
When is Y equal 1? What degree?
180.
90.
That's fine.
Okay. I typed
At 180, it's over here. Y is 0
I'm
right
at
there.
90. I'm at 90.
90. Crazy.
90.
Crazy. The biggest number, without adding to the parent, that he can be is 1. What is the littlest number he can be?
negative 1.
Negative 1. Which, I guess really negatives aren't small. That's not really how that works, but negatives are backwards. But you get what I meant.
The least amount it can possibly have.
Is 0.
Well, because
Yeah.
he could be in debt. Wouldn't that be less than 0?
Regarding money, that's true. That would be contextually
Is
true.
that now?
What about the sine of
What is the sign of 0? Don't use your calculator.
What is the sine of 0? It's
Sine of
0. It's 0.
Is 0.
That's what I thought, but you didn't say yes.
We just said that what is the sign of pi over 2?
That's 1.
What is the sign of pi?
0.
0.
I'm gonna guess it's negative.
What is the sign of 3 pi over 2?
Negative.
Back down. Here, we're just following the unit circle. Here it's 0. Here it's 1. Here it's 0. Here it's negative 1. Right?
There, it's negative 0.
What?
And what's the sign of 2 pi?
0.
Let's get a bit more granularity on here.
0 is negative or positive. I was just like,
1.
For this one.
4.
0 is
What is the sign of pi over 4?
Say that again?
0.5.
Can we use our calculators for this?
Are you asking
No.
positive?
Dang it.
1/2.
Wait a minute.
Boy.
Positive.
It is 1/2.
Yay!
I
That
thought
makes
you had-
sense.
Okay, I thought you. Okay, different signs.
Probably alone, I was listening there, that's irregular.
I heard sign and I thought positive or negative, not.
What is the SIG in of pi over 4?
Yeah. Positive, easily.
What's the sign of
Negative 1/2.
3 pi over 4?
Negative 1/2.
No. Wouldn't it just be 1/2?
It would be 1/2.
No.
Oh shoot, I was just going with the pattern.
Now, see, 5 pi over 4 would be negative 1/2.
So
Oh,
when you
yeah, now
connect
you
the
follow
dots
this.
and we add some more dots,
It's a squiggly line.
it looks like this.
Look at that squiggly line.
But it doesn't stop there.
It just keeps going.
It keeps going on and on and on. When is get back to 1?
At
2.5 pi.
the next.
What is that? We don't want to mix numbers.
5 pi
5
over
pi over
2.
2.
5 pi over 2.
This makes sense. More than the other pair of functions, at least.
Really?
Pair of functions.
The other pair of functions were easy.
I got like 60s on all those tests.
What is this guy talking?
The other pair of functions were so easy. They were. You just had to remember what they did. Yeah. Exactly. And he doesn't know how to remember things. Exactly. He sucks at remembering.
What we have just drawn, by we I mean me, because it seems like most of y'all are doing nothing.
We
It's
drew
there.
it. We drew it. It's
Answer
right there.
your
It's right here.
It is there.
It's right here.
I'm actually drawn. Reese is not.
Look at my squiggly line.
What we have just drawn is 2 periods of the sine function.
Ah. So is a period every 2 pi?
For sine, yes. It repeats every 2 pi. Starts here, and then it starts over at 2 pi.
Ah.
So we're gonna like measure stuff in. That's 3 periods.
That is a thing that will be discussed, yes.
Okey dokey. I have a feeling.
Let's get the cosine pair function. We'll just do 1 period of it while we're, so we can, I'm gonna do this. So we can compare that.
Wait, does that mean cosecant is just the opposite, like on the other side?
Definitely not.
Aw.
Oh, what do you
No,
mean
the
the
other
other
just
side?
think it was negative pi over 4. and
Do you mean like
negative pi
flipped,
over-
like
Yeah.
over the
That's
x-axis?
what I was saying.
Isn't
No,
that?
that's cosine.
That's cosine.
So is it on the y-axis if it's cosecant and secant?
What is something cosecant has that cosine and sine don't have?
A 1.
What?
Because it's
A,
1 over the function.
a friggin' quotient. What is that friggin'
It
word?
has places where it's undefined.
Yeah,
Lots
yeah,
of
yeah.
them. So let me find where, is that the next one?
So if it's undefined there, what's gonna be there on the graph?
Nothing.
No, it's.
A hole.
It's gonna be an asymptote there.
No, not asymptote.
Look at the cosecant, or what is this?
I'm gonna plug
No,
that
this
into
is
my
tangent.
calculator.
Look at tangent.
Tangent looks gay.
Okay, we're here now. We'll go back to where we are. Okay.
Pi over 2 is
So-
-1.
What is cosine of 0?
Cosine of 0?
0.
Is 0. No, it's not.
No, it's not.
No, it's not.
Cosine of 0 is 1.
Cosine of 0 is 1. Cosine is x. At 0, it's 1. And then at pi over 2, it's 0. Right? It starts here and goes down to here. At pi, where is he?
1.
-1.
Negative 1. And then 3 pi over 2, where is it?
0.
0.
And then 2 pi. No, 2 pi.
So what is the period of a cosine function?
What are you asking?
When does it repeat?
Every 2 pi.
Every 2 pi.
Heck
Sine and
yeah.
cosine have the same period. You're learning these, and you're trying to remember, just like be able to reproduce quickly what you're trying to do. Sine, 1 period of it, looks like a sideways S. Sine starts with S, and cosine kind of looks like a U. Making sense so far?
Yes.
Yes.
The difficult part is never the parents, though. It's always the children. So let's talk about changing it.
No.
Let's talk about smooshing it,
Oh,
and
phooey.
stretching it, and shifting it.
Function smooth.
Let's introduce some more new words.
No.
Don't sine waves have something to do with sound and like?
Yes. Yes. Anything that exists in waves can be modeled with trig functions.
That's great.
That is
I don't think there's a lot of word problems about that.
There's a lot of real world problems about that. Literally.
literally is definitely
Yeah,
true.
it's true. What about it?
What about it? He's just saying.
Zesty response I've ever heard.
That's
Yeah, it's true.
That's-
What about it?
I don't remember which
That's exactly how you
language
sound.
this
Yeah,
one
it's
is.
true. What about
Dude, he sounds zesty as that right there.
Yeah, it's true.
What about it?
it? Take care of that.
Does it not just give us-
Golfing.
There it is. Okay, yeah, it uses ABCs. That's what I thought. That's what I thought.
He's gonna sign your half for
I will do this.
It's a trash pencil, anyways. It's a trash pencil, anyways.
He's gonna sign your half for you later.
Use C's and D's there.
Oh yeah, there's no lead left in.
A, B, C, D.
Just put more in.
This, yeah.
Also, yeah, that's what I thought. Okay. I don't really like that, but that's fine. There are two versions of this equation. We're gonna use the one the book uses.
No,
You will also see ones where this is a minus, which I like better, but we're not gonna worry about that.
that's not this book. Stupid book.
What?
What would that change? Well, it would change
Things.
the direction. Yeah, I get that. Never mind. Is C still the direction horizontally?
What?
Is C still the direction horizontally? It moves?
Let's get there.
Okay.
We're gonna get some new words to describe some of these things.
I don't want
Okay.
that yet.
A has a name.
Apple.
A changes something specific. It changes amplitude.
Like an amp.
And what it changes on the parent is how high up or how low it goes, which makes sense if you think about it. Right? Because normal sine function only goes up to 1 and down to -1. Then, yeah, if you multiply that times 2, 2 times 1 is 2.
Whoa.
No.
So it would go up to 2 and down to -2. Other than that, it would look exactly the same. So it would go, etc. Right? The change is how tall it is. This variable matches our expectation from previous things, right? Easy peasy. These variables, some of these variables, always kind of make me laugh, and it didn't really dawn on me until I was in a class in the electrical engineering department at Tech, and in that class, you know, we learn all this stuff right now, and you see it in other math classes. In that class, you learn what phase shift is. First thing we do is do the math to kill the phase shift, make it go away, because it's pointless, because the thing keeps going forever and ever and ever, so phase shift is useless.
Patient.
Don't worry, we'll get there.
Okay.
Sounds cool. We don't need phase shifts.
I love shifting phases. Oh yeah.
We already learned one of the words, right? We learned the
Amplitude.
period,
Oh, the
right?
period.
We also learned amplitude. The period. So the period isn't always 2 pi. You can change the period.
Ooh, that's so great.
Is that the B?
Is that the B? That's a good question.
I would bet that is the B.
You bet that is the B.
How did my
Because
brain
B
just go
usually
there?
changes the
I
horizontal.
was thinking I could make a new
True
animational
enough.
So
superhero.
that would
The
change.
To
phase shift.
find the period,
Yes.
you use a little formula. Are you ready?
Uh-oh.
Okie dokie.
What is the period normally?
2
2 pi. So you take 2 pi and you divide it by the absolute value of B.
What is playing? I'm hearing like noises in like that corner.
Yeah, for sure. It sounds like someone playing Call of Duty.
What are you talking about?
It's not there right now.
There were some kids outside, which is probably
Really
what y'all are
playing
thinking.
Call of Duty?
Okay.
I heard gunshots, I swear.
What?
There's also
I didn't hear.
construction across the street.
Ah.
Oh my goodness. Do they use a T for period, I don't always make sure. There are different notations. And one of the reasons for some of that is like, it's especially bad when you get to like calculus, because two people invented calculus at the same time. One of them used one notation and the other one used another one. And so you never know what you're doing. I just gotta double check and make sure which notation this book is using. It doesn't use a letter at all. Great. Period equals that. Period is that. It doesn't use any of those letters. Great. Does it use a fancy F for frequency? No. It just says frequency equals that. Great. So, you have heard the term frequency before.
Yes.
Yes.
What is that?
How
Isn't it
often
like it
does
something
the thing?
happens?
How?
How often something.
So yes, the literary definition is that. And the scientific definition is the same, essentially, right? It's how quickly the thing repeats. So it's related to the period, how long the period is. The period is how long it is, and the frequency is how often it happens. So the frequency is calculated like this. Absolute value of b over 2 pi. Oh,
No.
that's a dumb question. What do you mean, what's the difference?
No, in period versus frequency.
Frequency is how often something happens. Period
Wait, never
is.
mind, that doesn't matter because it's correlated both to be, never mind.
Yeah.
So the frequency of a parent function is 1/2 pi.
Yes.
So every like 1/2
Every 2
pi
Yes,
units.
yes, yes,
Every
yes.
2 pi repeats.
What else do we need to know? The phase shift. Okay, this is the phase shift.
The phase
This will
shift.
require a-
Phase shift.
Phase shift sounds like a superhero name.
Probably is, honestly.
phase shift. You're correct on which letter it is when you guessed earlier. The phase shift has to do with the C. Has to do with where the graph is and how it's in phase or out of phase. There are some applications for phase shift because if you want sound waves to be in phase or out of phase a certain amount. What you might notice is this is sine of 2 times sine x. Cosine of 2 times cosine of x would be this just phase shifted back. Right? Cosine and sine, you can always convert between cosine and sine or whatever else. That's another thing. And as you usually do when you're talking about signal processing and you're talking about harmonics and all those things, is usually if you've got multiple trig functions, you usually take them all and turn them all into one thing. And in my experience, it was cosine. That may not be industry standard, I have no idea. But in the class I was in, we turned everything to cosine.
So the phase shift like equation would be like 2 pi minus c, wouldn't it?
Would be 2 pi minus c. Is that what you're saying?
That's what my guess is.
That's what your guess is. It is negative
Negative
c,
C
over b.
over b. Huh. Oh, because of I forgot about.
So
B
that,
determines
by
phase.
the way, answers your question from earlier. What difference would it make? Whether this was minus or plus, that's what difference it would make. That would be a positive one. Which is how it works in like all the other parents.
Yeah, because it's
So,
always,
that's why I like the other one better, personally.
yeah,
but-
because it's always
but-
negative going.
This is the way the book does it, so to keep our consistency, that's how it goes. Because the other one keeps my phrase of inside opposite and all that stuff.
Yeah.
Right? But this is how you find the phase shift of a parabola as well. We don't call it the phase shift, we call it a horizontal translation, but if b has changed, you have to divide it.
So is it negative c, or once you divide it, then it becomes negative? Well, that doesn't change anything, never mind.
What? Never mind. Fractions are fractions.
Fractions are fractions.
Because absolute value changes it.
The vertical shift is the stupidest of all.
Okay.
Wait a minute. Is it stupid?
It's vaguely pointless.
Is it never used?
We're just
Vertical shift is D, right?
Yeah.
ease nuts.
What?
The midline would be Y equals D, right?
Yes.
Easy peasy, lemon squeezy. Let's do some examples.
So is D never used, really?
Well, it's not that it's never used. It's just that it's less useful in real world applications. You're more likely to see combinations of trig functions, which is what harmonics does. And then you end up getting, instead of nice graphs that look like that, you end up getting graphs that look like, oh, you get stuff shoved together. Right?
Went through the phase shift.
We went through the phase shift. Let's do an example or two.
Or more than that, probably.
I don't think so. 12:15.
12:50. I thought it was 12:13.
It don't matter.
Same
2
thing.
minutes.
12:14.
I'm gonna smack you.
Just go ahead.
Digital watches
Actually,
ruined
oh my
people's
God.
lives. Have y'all noticed that?
What?
I think we're gonna do this a little bit different than what I was gonna say. Let's do problem. We don't wanna do basics.
So
Let's start with problem number 19.
with for homework, or are we doing that?
This is not homework, we're doing that as practice.
With D, does it just move the entire function
Up or
down versus if it was positive or negative? Positive is up, negative is negative.
It works exactly like you would think it would work. So we're gonna do page 264, number 19. Let's start.
There is no amplitude.
Y equals the sine of x plus 5 pi over 6 plus 4. So, you may have noticed when you may or may not have thought, well, I don't know about noticed is the wrong word. You might have thought about the fact that when you were graphing parabolas and stuff, you could basically draw a parabola and then shove an axis wherever it goes.
Yeah.
Which is kind of how I think about this. Because really, you can make every graph look the same and just label the axes different. Which is basically what we're doing. We need to figure out what numbers to write on the axes, and that's really what we're looking for. They're all going to look like this. All of them. Every single one. Right? So, what all is changed from the parent?
The phase shift.
And the vertical shift.
Vertical shift.
Phase shift, vertical shift. Vertical shift is easy, just move it all up. Easy money,
And then
right?
phase shift is.
So we need to figure out what the phase shift is.
Is 5 pi over 6 over 1, which is just 5 pi over 6.
5 pi over 6 over 1. So it's shifted to the right or to the left?
I would think
It's
left.
negative.
Left is the way it's
So
shifted.
yeah, it's a lot. It's negative 5 pi.
So it's shifted to the left 5 pi over 6. The instruction, I don't know what the instructions say? 2 periods, great. It can be any 2 periods. You could do any
Oh, so
whatever.
it just has to be 2 periods, not 2 periods in both directions.
It doesn't have to be. But that's often easier, because you can just kind of repeat numbers or whatever, but not always. We'll do it only in the positive direction on this one, because why not? Well, we'll need a little bit of the negative direction, because we're shifting it over negative.
We're shifting it over almost pi.
We are shifting it over almost pi.
Almost pi.
So, our normal numbers that we're putting on our axes in in one period are 0, pi over 2, pi, 3 pi over 2, and 2 pi. We just need the new version of that. So what is 0 minus 5 pi over 6?
Negative.
Negative 5 pi over 6.
Wow. Intuitive.
Wow, this is it. If we have pi in the numerator.
I don't know what I'm right thinking about.
We always have pi in the numerator.
Great.
Ooh, we always have pi in the numerator.
So what's 5 pi over 2? No. What is pi over 2 minus 5 pi over 6?
Pi over 2 minus. Wait, where did we get that from?
2 pi over 6.
The next number we normally graph.
Oh,
Pi over
right,
three.
right. Pi over 2.
So pi over 2 minus 5 pi over 6.
Negative.
It's
Negative.
This would be 12 pi over 6, right?
Negative.
12 minus 5.
no. It would be 6
or
pi over.
3 pi over 6.
Or sorry, 3 pi over 6. Yes.
So it would be.
Oh yeah, it would be 3 pi over 6.
Negative 1/3 pi. Negative pi over 3.
Negative pi over 3.
Yeah.
Or we could
Negative
just step
pi.
it up and half pi every time, could we not?
That is what you're doing. Yeah, if you want to think about it that way, that's fine. What's pi minus 5 pi over 6?
That's 1
Pi over
1/6
6.
pi. Yeah, pi over 6.
What's 3 pi over 2 minus 5 pi over 6?
3 pi over 2.
2 pi over 3. I keep trying to say 2/3 pi.
And what's 2 pi minus 5 pi over 6?
7
Minus
pi over 6.
Yeah, 7. Yeah.
Now we have to do that again.
You gotta do that again. What's 5 pi over 2 minus 5 pi over 6?
It is. What's half pi? Is 10.
15. So
Holy
yeah,
cow,
it's 10 pi over
yeah.
6.
Yes. 5
10 pi over 6 is
5
reducible.
pi over
Which is so it's 5
Keep
pi over
trying to
3.
say
5
it.
3rd.
5.
Okay, for the sake of time and getting, because I want to get at least one of this other kind of problem example. Let's go ahead and graph what we got. You would continue on down to a full 2 periods worth. What is the sign? We're doing signs. What is the sign of 0 normally?
0. But we gotta bump it up.
I know.
So it's
All right, so we got to go up 4. All right, up 1, 2, 3, 4. It's normally 0, right? So right here is the 0. You can. It's not a bad idea at all. It would be to dot in the new midline. Definitely something you can do.
Let me grab my little straight edge. My little straight edge.
I thought you said.
So I will tell you, you can use your calculator to help you on these. If I remember correctly, there is at least one on the no calculator section.
I would just be using the to help me add fractions. It's
Right. And if you want to have a scientific calculator or something for that, that's fine. Like to double check your things, that's fine. I don't care about that. And then over here at pi over 2, where is it?
It's at half.
1 normally, right? So that's up here.
Wait, is it pi? Yeah, it's pi. Hold on. Yeah, sorry.
So it's at 5.
So it's at 5. And then at the next one, where is it?
It's
In the,
0.
0 and then negative 1.
And then negative 1, which is positive 3 on this one.
and then 0.
And then 0. And back up to 1. Then you graph it, right? Easy peasy. No big dealio?
Yeah.
Right. Let's do one like number 11 on the same page.
11.
Some function to use to model the initial period.
it says write a sine function that can be used to model the initial behavior of a sound wave with the frequency and amplitude given. So you are given a frequency of 932. Excuse me. And an amplitude of 0.25. Okay? Alright,
How did we get the vertical shift?
there isn't one. There isn't one at all. Alright, so what letters are associated with frequency?
B and it's just B. It's just B.
So we need to figure out what B is. So frequency equals what?
Absolute value of B over 2 pi.
Over 2 pi. So 932 equals absolute value of B over 2 pi. So what do we do now?
Now we gotta, wait, yeah, now we gotta multiply times, what am I saying?
We
Yes.
could multiply by 2 pi.
Yes.
Multiply by 2 pi, that's true. What's 932 times 2?
It's something. It's
800,
probably like
1864.
1864.
Did you do that on your calculator?
No, I didn't.
Good.
4 times 5. Oh, we're just gonna leave this one up, it's great.
That's wonderful. Now what are we gonna do?
Writing an equation.
Sounds great. There's no discuss a phase shift, right?
Well, cause we'd have to have another equation.
We'd have to have more information, right? So, y equals, what did it say, sine function? What did it say?
Yeah, sine function y equals point.
Y equals 0.25 times the sine of what?
1864 pi x.
X.
We were so in sync there. So in sync.
Great, we did it.
Yay!
Easy money.
That's it?
Let's see, what time is it? Is there anything else that I need to tell you to do?
Other than, I don't know.
Not really.
What's our homework?
Homework is page 264.
No way.
Numbers 2 through
Yeah, let's just do no.
22 evens.
Okay, that's not.
That's not bad. Considering we gotta go through, what, like 60, 58 last time? Like 48.
Like 62 and then 58, 48. So now a nice 22.
Some of them take longer than the other ones.
That's true, but it's not that much longer.
No.
All in all, I think it'll be a little bit shorter. Maybe.